example, today I will go for a mobile application. I will design this this diagram that we see here. Let me just highlight. So as we can see, we have a set of 3 NG6 valve. We have some cartridge. It's a circuit sequence of cylinders and some solenoid valves. I will be using today the interface between HyDraw and MDTools. So I will import the schematic into MDTools and will design. Like the previous webinars, I will be using MDTools 780 for Inventor. Although we have also a version available for SolidWorks. The behavior is not different between the two. And probably next month I will be featuring, I will be using the newest MDTools 975, which is coming. I have an alpha version now, but I don't like to show an alpha version in a webinar. Maybe if I have a beta next time, I will try to use MDTools for SolidWorks, the newer version. So we'll see the improvement that we are making in SolidWorks also. So let's start our design. So when we look at the diagram, if we design on paper, we need to read our schematic. So this kind of manifold, mobile manifold, usually are a bit complicated because as we see here, we have a net. So we need to make sure to connect port 2 of item 2.2, port 1 of this item, port 1 of this item, and port C2 minus. So for HyDraw, this is called a net, and the same concept is applied to MDTools. The advantage of the integration between HydroCAD and MDTools is that HydroCAD is able to directly find the net. We can click next. Okay, so sorry, I'm using the latest 2021 beta, which I will be featuring for HydroCAD next week. So I'm testing a bit also the beta version of HydroCAD. So as you can see here, HydroCAD, I run a command called the net list, and HydRaw is able to find exactly the net. And the net that I had highlighted earlier, you can see that it is described exactly by a list of port. C2 minus is connected with the item 4.2 port 1, is connected to item 2.2 port 2, and is connected to item 3.2 port 1. Normally, when we design with the diagram on paper, we need to make sure, pay attention that all the connections are made properly. Today, we see how easy is the design in MDTools by importing directly this diagram. The second important information that we need to have in HydroCAD when we export to MDTools is that each component must have a cavity name. So as you see here, we have a cavity. Today, I will be using HIDAC component. So FC10-2, cavity 10120A, and so on. And this is a standard NG6 DO3. Okay, let's export to MDTools our diagram, and we go to our design process. So we click MDTools. We select just the part of diagram that we need to design. And we have this dialog on the left. I'm not going through. We already had a webinar about how to specify more information in the export to MDTools. We will have more in the coming months, but now I just skip it and go export and save my diagram into let's call it webinar MDTools 780. So I am exporting the information of the diagram into an XML file, and now I'm jumping to MDTools, in this case in Inventor, but maybe next time I'll do the same exercise in SolidWorks. So I start a new part, and feel free to post questions, if any, during the presentation. MDTools comes with a huge library of cavities and footprints. Normally, we start with the block. You can define standard materials and cross sections in your library, but normally I just start with a cross sections that make sense. So in this case, maybe 150 by 100 by 100. This is the starting dimension of my block. I know it is going to change for sure because I'm not copying something that has already been designed. I'm just starting my design, and with my experience, I start with a block that I find it makes sense. So normally, if you don't start with a HyDraw diagram, you will go into the cavity library. You will look for the component. Let's say I need a FC10-2 heater. I find the cavity, and the cavity has 2 ports. And here it is where we define the net name. So in this case, maybe one net is called pressure, the other net is called tank, and the component is maybe item RV1. We click insert and place the cavity in the drawing. And then we can go on, we can select more cavities and place. When we define this net name manually, we are basically instructing the information that are present in the diagram manually. So if you have a diagram on paper or on PDF or on just pure AutoCAD, you can just specify a net name to those line segments that were in the diagram and insert the components. But today we are designing from HyDraw, so we will import directly the schematic from HyDraw. So import this webinar MDTools 780. When we import a diagram made with HyDraw in a block that has already been designed, I cannot say that this block has been designed, but there is already a cavity here. So maybe this cavity is not fitting with the diagram. So we always can compare the block with the schematic. This is just a simple exercise. I could just delete it. But if we compare the schematic with a block that is in the drawing, and by starting the comparison, we can see a lot of issues here. And for instance, we can see that there are a lot of missing components, everything basically. I didn't put any single item from the list in the HyDraw diagram, and I have an additional component which is not there. RV1 is not in the list of components. If I manually rename this item, instead of RV1, I call it 2.1, which is basically a component that is in the schematic. We can see it here. 2.1 is there. So if we manually specify a component that is already in the diagram, we know that it is exactly the item 2.1. We can click OK. And now, as you can see, this item is grayed out. It is already in the block. It may not have correct net information. In fact, now we run the schematic check again, and we will see that now there is no extra component, but there is a component 2.1 which has wrong net. So the net should not be P and T, should be net 8 and net 6. And here we can just go and say edit this cavity and make it 0.1 is net 8, net minus 8, and the port T is net minus 6. Okay, and now I start, and now there are no issues. So this component is exactly how it should be corresponding to the diagram. But it does not make sense to place manually components and try to match the net manually. It does make sense to directly double click on the item, touch a face, and position the component. So let's start really our design. So we first placed our NG6 valve, and automatically we see that we have engraving item 5. Item 5 is grayed out. Item 2.1 is not grayed, has no engraving. We can manually add an engraving. Manage, attach to this cavity, and place the engraving 2.1, engrave. Any component that we place directly from the HyDraw menu will be placed with engraving. Anything that you place manually from HyDraw, from MDTools library, will not have engraving. So it's very handy because here it is very easy to identify which component we have. Now let's start designing really our block. Normally my approach is not selecting the cavities and placing them. I always try to first place the most relevant cavity. In this case, it's only this NG6 valve. And then I go by nets. Going by nets really helped me finding all the connectivity. So I can say net 6, I have a C1 minus, which we can place it on this face, and maybe I can connect it directly with the same color with a 7mm diameter. Now I want to take this 4.1 and I can see that it is port 1. So I can envision that maybe this cavity, I can place it on the right face and with the port 1 connecting directly here. So let's do that. Double click on 4.1. I put on the left face and connect with that one. Maybe I put it somewhere here and with a 10mm diameter. And this is making a connection. Let me clean. I see that there is this cavity, and maybe this one is better if I move it on the opposite face, on the opposite side of the block. And that makes sense. I can just do a connect this one with 2.1, which port I connect to port number 2. It is the top port. As you see, we have a preview of the cavity. I don't want to be center, I want to be tangent. So I want to enter here, tangent. So we can click on this command here and it is making the tangent connection. Okay, and now we made a good connection here. So looks like now we have completed one net. Net 6 was made of item 5 port A, item 2.1 port 2, item 4.1 port 1, and C1 minus. This is good, and with the same approach, we do the rest. Anytime during the design, we can do a verification of what is missing. We can do a connection check. Let me make an example here. If I stretch this drill and make it too short, and I do the connection check in my block, now I see a lot of issues. So if I touch any of them, I can see that 2.1 port 2 is not connected. 2.1 port 1 is not connected, and a lot of net are broken. So in this net, we find also the net 6, which is the purple one. So now if I make the connection and run again the connection check, this net 6 will not be listed anymore. So we do that connection again. And now if we run again the connection check, net 6 is not there anymore, and also item 2.1 port 2 is not there. So this connection check will always give us warning if we have problems in our connections in our block. Let's move forward. We go on the green net, C3 minus, and maybe we put it here and connect with the green one with a 7mm diameter. When you place a cavity, you may find very useful the position with respect from another cavity. To do that, let's say that this cavity here, I want to place exactly on the same vertical axis at, let's say, 40mm. So to do that, we click reference and select the C1. So we click reference, we touch the C1, the origin is moving, and now we can just say 0, 40. And there we have exactly the position at 0, 40mm from the other place. Of course, we want to move this cavity out, so let's do a change face and position it maybe on this side. We go on with the green one. Green one has nothing else. I need the construction ports. So now in my design, I want, let me save my block. In my design, I want to use expander plugs. So if you want to set a category of plugs, you can go to the settings and you go to the exports. And by default, I always use BSP plugs, but now let me remove and I want to use expander plugs. So I go and select my expander library, all, and add to my design. And I click apply. And I'm done. Now I can make construction plugs with expanders. So to make construction plugs, I use this command, which is called export. So export, I touch my port number 2. I can select a different size. Let's say MB 680 is okay on this face. We can align cavities. So to align cavities, we can also do align multiple cavities. Align multiple cavities, I want to align these 2 cavities with this one, and this will make in the good alignment. We can make another construction plug between this okay, and we place on this position, and we can put the cavity somewhere here. Let's move it slightly to the left. Okay, let's go on. We go by net. Net 2 has only the port P. Let's say that P port must be on the right face. P port, we place it here. And this is fine. We can leave it here. And we can stretch this cavity slightly here. Now, let's say that instead of making a plug, I want to make an inclined connection. So I can do a stretch for this drill. With inclination, I want to go directly to this cavity. We have a preview. If we don't like, we can change the inclination. Let's make it 15 degrees, and let's make it 50 millimeters deep. Now, MDTools is creating an inclined drill for us. We also take the tank net. Let's go to cavities. I want the T net, the T port, which I want to place somewhere here, and click OK. And we can see some problems. Let's move it. This one here. And let's position this cavity somewhere here. Now I'd like to make a connection. Well, we can move everything up here, move multiple, and move on the Y direction. 2 steps should be enough. Now I want to change the inclination for this drill. Maybe we make it 20, and we can reduce the depth. We make it 40 millimeters. Now there is room. I can stretch this drill, make it long enough. We can reduce the drill. 20 is large enough. Okay, and I can do an inclined drill also here. Stretch, allowing chain going here, and maybe just 10 degrees is okay. And now we have made part of our connection. Let's go on. Let's go by net, and we go on net 1 is complete, net 2 is complete, net 3 is complete, net 4 has several missing items, net 8 has something here, so let's place C2 plus. We want it to be here and connect with port 1 in the center. And we have 3.1. Let's place it and see how it's doing with the colors. This way, well, it's interesting. It could work. We make a construction plug on port number 2. Let's say always 80. And I connect also with port number 1. Let's keep always 80 on this face. And this is making the connection. We may not need such a large drill. We can stretch this drill and make in 10 millimeters. If you see some graphic artifacts in the block, just click color, and that will recolor automatically all the block. When an engraving is off the face, just click edit and move it. Let's go. So here we have this net. I need to connect, so I may need to move this cavity on this direction. I want to connect these nets. So let me just remove some material. So there is a command that allows us to remove material. So on the length, maybe here, I want just to remove 10 millimeters. So this command will stretch the block. My idea is to make this channel being on axis with that one. I want to connect somewhere from the top face or bottom face. Let's see if that is doable. Of course, I have this green drill, but we may delete and put it later. That's not relevant. I want an external port, item 2, always 8, and we put it here. And the position now we want to go on the Y direction and maybe also on the X direction. Here it should be okay. It's very close. Let's move up a bit this cavity. So 1, 2, 3 millimeters up. Okay, our log start. I don't like this drill. We may change face to this cavity 3.2. Let's go on. And now the net 8 is complete. We have net 7, which is only the C3. So let's say that C3 is okay on the opposite face. And we want to place exactly in the center. So we do the reference in the center at 0, 0. And if we want to make the same diameter, let's say that in previously, if you remember, I made this drill 10 millimeters. So now I want to apply the same drill to these two drills in order to have not many different drill diameter in my design. So to do that, we do the match properties. We select the source cavity, the destination cavity, and we decide what we want to copy. Let's say drill diameter. Okay, and now MDTools is making the same drill diameter. Again, we recolor to have a proper rendering of the connection. So also net 7 is complete, net 6 is complete, net 5 is completely missing. So let's start, well, let me move this cavity chain. Let me move it up. I'll see later how this connection are coming. C2 minus, let's put it on here and connect with port number 1. I didn't practice earlier, so I'm just checking with my vision of the block to see what can be a solution. You know that there are unlimited solutions to a manifold design. So really, the design comes by looking, by testing, checking which position. And it's nice that you have the possibility to change face, move, add material in order to find the best optimal solution that matches your need. Let me place some other components. This one is going to be here. And this looks okay. Let's take the C1 plus and place it down here and connect to port number 1 and position it here. I want to move this engraving. And this is good. I move this cavity slightly up. I create a construction plug going on port 2 on this space, tangent. And now I can connect straight down here. Copy this cavity. I want also on top and connect in here. And I can position here. If you want to have it center to center, well, we can say align this cavity with this one. This cavity with this one. And we can reduce the drill to 10 mm. As you can see, there may be situation where a drill is too long, like in this case. So this drill is very long compared to this one. You don't need to waste time in fixing all those issues. You can just run the check band command. So check band command is going through each cavity, each intersections in the block. And you can click all and update. So in this case, MDTools is fixing all the intersections, making the smooth intersection in all the situation in the block. Of course, you could select one by one and verify, but I normally trust and then do another connection check and verify if the connection is good. Let's quickly do finish, and let me place this cavity somewhere here. It starts becoming tricky, but we'll find a way to do all the connections. This is not bad. We copy this one on this face, connecting with port number 1 and the back. This is good. And the blue connection, net 5, we have really a bad position here for the connection, so we can just, let me see where I can find room. Okay, let's make a construction plug on port 2. This is okay. And let me just add 10 millimeters of material down. Maybe later we find how to optimize a bit more the block. And I will make my drill go in copy here. And now I can stretch my drill back here. Now I can make a connection just by doing an offset connection. So we can do a move multiple, these two cavities down. And this drill is not connecting. We can do an inclination. Also, we can incline this drill to item 2. And we can just reduce a bit the inclination. Let's say 95, 100 millimeters. We move this cavity slightly down in order to have a better intersection. And we color all. So looks like we have placed all the components. They are all grayed out. Let us verify. So we do the schematic check, start. And as you see, all the components are there. I see a small flow here. Let me go to component 4.2. And there is a net that should be a pressure. And save. So this report tells me that all the information I have for my block are matching exactly the schematic, but that does not tell me that the block is correct because I have not verified the connections in the block, and I didn't also verify the wall thickness in my block. So let's do all the checking that we need. Of course, I will need some mounting holes as well. So let me place mounting holes. Let's say I need just M8, 4 pieces on this face. And this is the mounting hole. Let's verify the connection check. Start. Okay, that's good. We have a broken net. Okay, that green connection. So easily we found out the problem. It's almost finished, but the green net is not completed. So we'll need to find a solution for that, and we do also now all the connections that are needed. Yes, I found a way to make the connection. Let me create a construction plug on port 2 on top. And let me take reference to the green drill that is behind. Reference with this one, at 0 mm. So it's center to center, and we copy and do the connection this with this one. Now we move the engraving. Let's do again verification. Connection check, start, and no issues. So now I am 100% confident that my block with a schematic check, I know that the information for the in the diagram are correct with what is in the block. Now I'm 100% sure that my block is also correctly connected. There are no wrong connection or open net. I'm not, I didn't verify the wall thickness. This is easy. Wall thickness, it's not a large block, so 4M will be enough for my design. And there are some issues. Let's go through. So here we have 3.5 mm. That's not a big deal. And then we go to the other one. Here we have 3 mm. Let's fix them. So we can just move this cavity down. And we have an option, update connecting cavity. This option will make the connection update. So if we move by 2 mm down, also the corresponding drill behind will be stretched by 2 mm. So now we have increased the wall thickness between the orange and the green one. And we also fix the other one. We do a move multiple. We move this drill and the port on the opposite face. And we move on the right by, let's say, 2 millimeters. This looks good. Let's do again the wall thickness check by 4 mm. And now we'll see that that issue has no, those two issues will not be there anymore. There are a clearance in the same net, which means a drill belonging to the same net with the same pressure can have a distance, like in this case. Normally, I don't care about this situation. So in my opinion, this one, in this case, are not relevant. So as you see here, MDTools is warning that there is a distance between these two drills of 1.42, but they are even connected. So that's really not a threat for the safety. There is an important warning here, clearness between spot face. So if two spot faces are too close, in this case, I don't think it's a big problem, but I could move the expander slightly up in order to have more room. And that can be a problem sometimes if you have a spot face too close one to each other for assembly reason. Let's say that our block is okay for us. So we do a save. I see an engraving that is rotated. Let me add again. Manage, touch the cavity, and place the engraving. And let me create the assembly. New assembly. And I can do automatic assembly. Since I have started with HyDraw and I had all the 3D models linked in HyDraw, let me show you. A component has also the 3D model down here. So each item, in this case, this sonar valve has a cartridge and coil. So now I want to place my component, my block. It's my block. And now MDTools is placing all the expander and all the cavities. We can rotate the coils. And the block looks good. Let me save it. That's our assembly. And now I want to share with my customer. So if I send this block to my customer, I don't want to give the internal details of my block. So I will make a shrink wrap That means a simplified model for my customer directly in a step format. Okay. And this is saving directly a step file, so it will take a few seconds or minutes depending on the complexity of the block, but it's a batch process. It's done. I'll open later with SolidWorks to show you the internal, but now I want also to make a machine drawing of block. So I create a new drawing. I will place the 6 views of my block, and I can decide where to put the 6th view. I want it on the right. I want to have the footprint outline. So this will add a BPNT port to the NG6 valve. As you can see, I have a direction for all the inclined drills. I can show the construction plug, so they are all marked with a X. I can add all the dimensions. And I can, for instance, in this case, use the machining callout for all the cavities. So now MDTools is just adding to each cavity, and what you need to do is just moving them around. Of course, we can make a drill chart, but let's not. Since I'm running out of time, we'll do the drill chart maybe next webinar. So as you see here, what you need to do is just move this machining callout in order not to overlap with other entities in the drawing. And the machining callout is listing all the details that you want for that cavity. So we have a SA port -10. The bottom drill is 15 by 78, and it is a spot face of 34.5 millimeter deep. Last, I want to open the shrink wrapped model. If you have any questions, please post it. So I can open that shrink wrapped model that I have just created. It is in the step file, and I can open. While SolidWorks is opening the file, well, here we see the block. I'll do something else. Well, here is the block. Before getting back there, I will export an MBXML file from my block. I discussed about MBXML file in one of January's webinars. This is our block MBXML file, and I'll show you how to use it in SolidWorks MDTools. So as you can see, my block assembly has been imported and there are no plugs. Actually, if I look at internal, let's look at the wireframe view. Should be. Looks like my, let me do something else, bodies. Okay, this is my body. Let me isolate all the other ones. This is my block. And as you can see, there are no construction plugs, no drills. It's only the cavity profile and the outer shape of the block with all the ports. So the block has not all the intelligence that we put in when doing the design. So this is a block that you can easily give to your customer. He can assemble in his machine, but he will not be able to machine because it is missing all the connection. I was willing to show you in 975. This is a beta. I'll show you just how to import the cavities in 975. So what I have designed in MDTools for Inventor, I can easily import in MDTools for for SolidWorks. So if you have a customer or supplier with a different platform using always MDTools, it is possible to recreate the same block just by importing the MBXML file. And now I have a native really conversion between a different format Inventor into SolidWorks, or vice versa through an MBXML file that has all the information for the, as you can see, the cavities and also for the engravings. And here it is.